All right, on this video, we're going to verify that the functions are inverses by showing f of g of x and g of f of x are the identity function, which means that they both have to equal x. Okay, so let's try this. I'm just showing you right now. This is the two problems I'm going to do on this video. The second one has to deal with these fractions right here. So if you just need to fast forward, and then we'll do this one. And I tried to make them very similar to what you're going to do on the homework, where you're kind of like filling in those boxes. Okay, so the first thing they want you to do is find f of g of x. Okay, this is just a tiny, tiny little open point like that. You could also write this. This is the exact same thing. This is f of g of x. Those two things are exactly the same, just another way to write them, okay? So don't let that bother you. So I think the very first step they're going to want you to do is take f and then say, well, what is g of x? Well, g of x is the fifth root of x over 2, okay? Well, how do you find f of this mess? You're going to take this, you're going to pick it up, and you're going to go put it in function f, wherever you see the x. So right here is function f. See that little x right there? You're going to stick this entire function right there. So I'm going to do 32. And instead of a boring x, I'm going to write this entire function. I'm going to stick it in parentheses. Fifth root of x over 2. And notice that's to the fifth power. And I'm looking through my phone, so hopefully this isn't too messy. Okay, remember order of operations, you do it's in parentheses first. So the fifth root of x to the fifth power, these cancel out and give me boring x. 2 to the fifth is 32. So these will cancel. Realize that's like 32 over 1 if that's hard for you to see, but these 32s will cancel, which gives you boring x. And you're like, yay, that's what I wanted. Okay, now let's go the other direction. You always, if you're proving their inverses, you have to go both ways. So now we have to go g of f of x, which, by the way, is g of f of x. Same exact thing. We haven't really done anything yet. So on we want to do is, what is f of x? So, well, f of x is 32x to the fifth. So I'm going to plug that in right here. Okay, so what does that mean? That means we're going to pick up this entire chunk and we're going to go put it into function g, wherever you see the x. And there's my x right there. So we've got the fifth root of x, but instead of boring x, we're going to put this whole thing in there. All over 2. Okay, so the fifth root of 32 is 2. Why? Because remember, 2 to the fifth is 32. And the fifth root of x to the fifth, these cancel, which give me a boring x, all over 2. Notice that cancels, which gives me boring x. Yay! Okay, that's what I wanted. Now, let's look at that yucky one with the fractions. Okay, are you ready? This one you got to be kind of careful with. It's not bad. These are, I'll show you here in a minute. Let's just go. F of g of x. That's what we want to find first, which is the same thing as f of g of x. I'm going to get writer's cramp. Good grief. So the first thing is we're going to just fill in what is g of x. Well, it's this gross little fraction, 2 over 3 minus x. What does that mean? You're going to pick up this entire chunk, okay, that entire piece right there, and you're going to go to function f. Here it is, and everywhere you see an x, 2 places right there, you have to plug this entire thing in both places. Okay, so let's just get started. 3, instead of an x, I'm going to put this entire fraction in there, 2 over 3 minus x. Then it says minus 2, okay, all over, and instead of the boring x, we're going to put in the entire function. Okay, this is what you call a complex fraction because it's a fraction over a fraction. That's okay, don't get stressed out. Here's a little trick. Whatever you see down here in the denominator, you're going to multiply both in the top and the bottom by that. So I'm going to multiply both of the top and the bottom by 3 minus x. Sounds like I need another cup of coffee. So I'm going to do it like that. Notice whenever you have the same thing over the same thing, it's 1, so everything works out great. Okay, so we're going to distribute this. Both of these things have to be multiplied by this 3 minus x. Well, notice here, they cancel. Do you see that? So I just have 3 times 2, which is 6. Now, I don't want to do too much at once, so I'm also going to take 3 minus x times n minus 2. So I'm going to write minus 2, and in parentheses, I'm going to write 3 minus x all over, okay? And then notice these cancel. Love it. So I have a boring 2 on the denominator. Now, the reason I took 2 steps is because this isn't just any old 2, it's a negative 2. So you got to be real careful when you distribute that in. Negative 2 times 3 is what? Negative 6. Negative 2 times a negative x is a positive 2x all over 2. Notice my 6's cancel, so I have 2x over 2, and then that cancels, and I get x, and I'm like, yahoo! Okay, all right, now we gotta go the other direction. Okay, so let's see if hopefully I left myself enough room for this, but we're gonna find g of f of x, which is the same thing as g of f of x. So what we're going to do is we're going to put function f in here first, which is that fraction. Okay, so what does that mean? I'm going to get another piece of paper here, because I think I kind of made myself run out of room. That's okay. So we're going to take this whole grossness, and we're going to go put that in function g wherever we see the x. Will you see the x right there? We're going to put this whole chunk right there. Okay, so that looks like this. Oh, I'm covering that up, silly. So g of x looks like this. We have a 2 all over 3 minus x, but instead of my x, I'm going to put my entire function. Okay, so it looks like that. All right. Did I just copy that down correctly? When you're looking through your phone, it's really weird. Okay, notice my denominator is an x here. So I'm going to multiply the top and the bottom by x, just like that. And I know you can write this as x minus 1. I think I did you don't have to. I guess I don't usually unless. Okay, so you get 2 times x, 3 times x, and then notice right here, I've got x. My x's are going to cancel. Now be really careful here. You might want to write this as at one step because it's minus this entire thing right here. So you're subtracting this entire piece, okay? Remember, this was one fraction. You were subtracting the whole thing. And the reason I'm saying in that is you're going to have to distribute that sign in. So you've got this 3x. That would give me minus 3x. And a minus is a plus 2. Okay, so notice 3x minus 3x, that cancels. So I have 2x over 2. Look at that, which gives me x. Bam, and you're done.